In this video, we're going to go through and construct all the data types that we need for our view matrix, our vectors for the location, and create a namespace that contains the offsets that we need. So I'm going to go ahead and go to our header files, right click, add new item, and I'm just going to create a .h. I'm going to call this one offsets. And I'm going to create a namespace. Let's call it zombies. And inside of here, I want to have, let's do, what would be a good name? We'll just leave it since we're only focusing on zombies. So we're going to have our addresses, and then inside of that, we're going to have actual offsets. So we want our entity list first. So we're going to uint pointer t entity list equals our value that we pasted in. So go ahead and include that so it quits complaining. And I want to index these with an A as they are an address. We have our location. I'm just going to actually copy these. And paste uint pointer t at the beginning of all of them. Like so. Oops, that is not an equal sign. Okay, so these are actually going to be offsets. So I'm going to create another namespace. So namespace offsets. Wrap around those. And we have one more normal address, which is our view matrix. So uint pointer t a view matrix equals that value. And I'm going to index these with O for offset. So we have our entity list, view matrix, location, health, and distance between entities, offsets. So let's go ahead and go up here. We're going to go ahead and include offsets.h. And that leads us to the next thing, which is actually going through and using my memory class. I went ahead and changed it up. I'm just going to go ahead and grab it. This will be a download in the description, but all it is just a header file. You download it, go to your project name, and you can just paste it right inside of, include. Come up here, go ahead and include memman.h. Statically linked. Now, wait, is it? I think so. Yeah. So go ahead and include memman. And I'm just going to go ahead and do a build, make sure there's no weird issues. I missed something dumb. Right. So memman uses an inline because I'm trying to do everything with statically. So we have to make sure we're on version of C++ version 17. So go to project name properties, go to VCC, no, C++, language, C++ language standard, change that to C++ 17 standard, apply, and OK. And now we should be able to compile, which we can, so we are good to go. So now we need to go through and do what we need to do. So obviously we have our while loop. So inside of here, let's comment what we have to do. So we want to get view matrix. Then we want to loop through entity list. Read, well, let's do get entity health, get entity location. Well, get entity health to check if greater than 0. Get the entity location. World to screen location. Draw to screen. So that's all we're really going to be doing. So we can go ahead and actually create some helper functions. First thing we need is actually another header. So let's create a new item. Let's just call this one helpers. And I already have a world to screen function that we're using because we are working with DirectX. So let me go find it. It's in the other tutorial. Being blind as a bat. Helpers. And I'm just going to copy convert to range and the world to screen, just like in the CSGO video. So you can go ahead and these will be, there will be a link to this project down in the description below to the GitHub repo. So you can just literally copy and paste it in. But we have some data types that we need. So we need a vector2 and a vector3. So we're going to go ahead and create another header for our data types. I'm going to go ahead and call it data types and begin. So we have a struct vec2, and that contains a float x and y. Then we have the exact same thing, but a vec3, which all it does is has a z coordinate. So let's go ahead and include in our helper.h data types.h, and that takes care of that for us. Compile and make sure we're good. Great. Now we just need a struct for the view matrix. So view matrix that contains an array of floats, 16 elements, or sorry, matrix containing 16 elements. And there we are. So when we go over to main, when we read the view matrix, all we do is view matrix. And I forgot to include data types. So let's go ahead and include data types.h and include helper.h. We get our view matrix. Let's call it matrix equals memman colon, because this is everything in here is static now. I'm going to go ahead and read memory of the type view matrix. And then we need our address. So if we go over here to offsets, we need to include our namespace, and we need to look at the view matrix address. So we're already including that. So what we can do is, instead of typing in, what was it? Zombies a view matrix, which is just fine. Actually, I'm going to probably leave it as such. No. We're going to go ahead and do using namespace zombies. I only want to use just the zombies because I want to indicate strongly that offsets are offsets, make it a little bit cleaner possibly, and check it. So we have our view matrix. What we can do now is print them out. So we're going to see out. Well, actually, no. We're going to leave it. But what we want to do is currently we do not actually have any sort of process or anything like that that we can really get a hold of. So when we call read mem, we are reading the process memory from a handle. Well, we have not done anything to indicate what that handle is. So if we scroll down to get process right here, we go through. I'm being completely blind as a bat. Here we have our handle. So pretty much if what's returned from get process is not 0, we will have a valid handle. But we're going to come up here after we create everything with our window. We're going to go ahead and get process. So we're going to do uint pointer t process equals memman get process, and then we have a string literal with the process name. So in our case, it's going to be the name of the game. So that was, I actually cannot remember. Odd Word at War .exe, and there's our process. So what we can do now is if process equals 0, we can do something with it, or better yet, we can put this right inside of a while loop, pretty much. So while that, wait, I got that backwards. Wait, did I? So while this, that should be true, we're going to loop. So yeah, I got that backwards. So can I actually compare that with something? So while this equals 0, so I want to actually go through and perform a do while instead. Nah, screw it. We're going to go back to the original way. Keep it very simple. We're going to see out process is invalid and just return -1. We have our process. Now we can read it. And we have our view matrix now. So now we need to loop through the entity list. So for, let's do a short int I equals 0. I is less than, I'm trying to think what the max amount of zombies can be on the map. Let's do like 40, something along those lines, and increment I each time. So now we need to get the address of an entity. So we're going to have a uint pointer t, entity equals memman, readmem, uint pointer t, and we have to go through the, where's offsets? The entity list. So we're going to get the A entity list plus I, so we know what index we're on, times the distance between each entity. So 88 bytes. So pretty much as the first index is going to be actually us in this case, we're going to jump down 88 bytes. That's going to lead us to the first zombie. And then after that, it's going to be another 88 bytes. So it's going to be the second zombie and so on. So this way we are, it was offsets, yeah, distance between. So this way it's going to go through and grab each individual entity. So the first one, this is going to be entity list plus 0, because I being 0 times the distance between the entities, 0. Anything multiplied by 0 is 0. Duh. So we're just going to start at the beginning of the entity list. Then after that, I is going to be 1. So it's going to be 1 times 88 bytes, which is what? 88 bytes, because anything times 1 is itself. So here we can do if entity, well, does not equal null. We can run through and do the rest. Or we can also do if entity equals null, even though I don't really like doing that kind of stuff anymore. Did I spell that wrong? We can do continue, which will just continue with the loop. It'll jump right over and start again. So now what we want to do is check something. So we want to get the entity's health. So we can do that by if, let's do int health equals memman, readmem, it's going to be an integer, entity plus the offset for health. So offsets, offset health. So actually, I don't know why I'm doing that in there. I was going to do a comparison, which I forgot I can't do like that. So if health is less than or equal to 0, we're just going to continue again like before. So here we go through and draw. So we do that check. And we want to go through, get the entity's location. Actually, just copy these guys. So now we have to get the entity location. So it's going to be a vec3 because we have an x, y, and z coordinate. So vec3 location equals memman, readmem. It's going to be of a vec3 entity plus offsets location. Now we should have the entity's location, in which case we world to screen it. So if we look at our world to screen function, returns a boolean, so pretty much it actually should say, yeah, right here. So if the entity is behind us, we are going to return false because we do not want to draw it. So if, what was it, world to screen, we have the vec origin and the vector2, which is our screen coordinates, and then their view matrix. So that's all it is. So what we're going to do is pass in the vec origin, which is the location. Then it outputs the information to our vec2, which we need to create. So vec2 screen chords, which we also pass in our view matrix. So where do we get that? Right here. So we have matrix dot matrix. So we have all the information there. So if this is true, what happens is we can go ahead and draw it to screen. So I want to check if it's false, because if it's false, that means the entity is behind us or out of the screen's view. So what we're going to do is just continue. Now we need to draw to screen. So we have our screen coordinates here that we have that the word screen has given us. Also, one more thing that I really want to point out is in the helper.h, you have to make sure these can correspond to your monitor's resolution. So currently I'm 2560 by 1440. You have to make sure you do the same. So what I'm going to do is, let's see, we want to draw to screen. So it's GL begin, GL lines, indicating that we want to draw lines. It's a GL vertex 2F. So that takes in an X and a Y. So that's going to be our first, like our starting point. So these are pretty much points on our screen. So I want it to be right here at the center bottom. So we work from -1 to +1 in this case. So -1 on the y-axis is all the way down. +1 is all the way up. 0 is right in the center. And x all the way to the left is -1. All the way to the right is +1. And 0 is center. So we want the center on this x-axis, so 0.0, and bottom, so -1.0. Then we want the line to go to the entity. So we have the starting point, which is going to be right here. Now, if the enemy is over here, I want it to go from here straight across to there. So GL vertex 2F, screen chords.x, and screen chords.y, and then GL end. So this should hopefully draw our ESP. Let's go ahead and compile, and I'm gonna launch the game and see, what all happens. And hopefully I can actually load it up in the proper resolution without throwing a fit. Cool. Last time I was stuck at 1080. Just get that close there. And actually, I just realized we're not entirely done yet because we have to do other stuff to our actual window. Position that a little bit better. Visual commands, so don't die or anything like that. So if we press F5, we're pretty much going to be drawing to this, but there's nothing there. And for some odd reason, it is hiding my window, so I'm going to go ahead and make it show it. It was, what was it? Show window, get console window, you probably don't have to do this. In my case, it's just, there it goes. Now it shows the console window. So it's not printing out process is invalid, so we are getting the process. And we are pretty much good to go. So what we're going to do now is we have to do a couple things to modify our window. So obviously we have to change these to our screen's resolution. So in my case, it's 2560 by 1440. And now when I run it, it should fill the screen. Like so. Now we have to do a couple other things, and I do not remember exactly which hints they were. But if we come back here, I'm going to just do a quick skim through. Okay, so we want to make it floating, non-resizable, maximized, and transparent. And then we want to make sure the title bar is hidden. So I'm going to copy these and paste them in. And we do that right before we create our window. So it's GLFW window hint, GLFW floating, that's true. Resizable is false. Maximized is true. And transparent is also true. And then we do the exact same thing, except we have to do this after the window is created, where we go through, and I want to make sure you are actually a capital W because I hate it when it's all lowercase like that. Then after that's created, we have to hide the title bar. And that's something that kind of annoys me a little bit because for whatever reason, if you do it beforehand, it doesn't work as you think it would. So everywhere where it says window, let's go ahead and just paste it with capital W, or if you ignored it, that's fine too. So now when we run it, Press F5. Great. However, we have the problem of I can't, well, actually I can click through you. But we can actually see the line. And now that I brought it up again to the full screen, I can't click or do anything. So we have an issue that we have to fix as well. So I'm going to close out of it. Did I close out of... I did. Dang it. I closed out of the game. Let me relaunch it. Yada, 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 yada. Oh, heck yeah, it's not going to actually show my resolution again. And now it does. Makes complete sense. Select the same crap. Still slightly off. There we go. So, there we have it. Let's go ahead and double check and see what we missed. So the first one being, we want to make sure our mouse can actually click through it. So that's just going to be another hint. So glfw, window hint. It's glfw underscore, oh, what is it? It's like mouse click through. Could be anyways. What's under mouse? Oh, mouse pass through. We want to set that to true. So this allows it so when we run our window, even though we can't see it right now, but I can still click on stuff behind it. I can drag our console window, even though it's all the way up top. So when I come back down, I'm going to back to our game, we can see that it's up top. So here we have some lines being drawn. We have one at the center of the world for some odd reason. Not sure what the cause of that is. We have two lines there, and look at that. They are pointing right to zombies. We have another one over here. We have another one over here. They are snapping right to the origin of each zombie. We got to get rid of that guy. Just like so. So my guess is this is kind of acting as our local player. So we want to jump over that first index. I'm going to close down the project, go down to our for loop, and we can actually probably fix this by just simply setting our starting index to 1. So at least in our case. Let's try it. Oh, we are still at the origin point. And what is that supposed to be drawing to? Like, is there just something there? No. That's just this. My guess is that's the center of the world, and for whatever reason, it's actually drawing to it. So I'm going to try something. Let's just try, we'll still be at 0. Let's bump it up a little bit. So we have our entity list. Let's bump it up 4 bytes. Run it and check. And now we have another issue where it's not drawing to the entities, but instead drawing directly to that line. Oh, wait, no, not 4 bytes. I'm an idiot. We want to go up, oops, 88 bytes. That's right. That's my fault. So we do 18E73C0 plus 88. Paste in this value here. And that's going to be our new starting point. Run away. And it's still there. So I really have no clue what that is supposed to be, but there's probably other factors that we can account for to see if it's a valid entity. So what I'm going to do is I'm going to look through Cheat Engine and see what all there is. So long story short, if you don't care about it, don't even bother watching the rest of the video. You're pretty much done. I'm going to go ahead and check. Let's look back at the entity list here. Control B, Control D, structure. And this should be actually, I think, the first entity, which is us. So 1CA, yeah, that's us. Go down 88 bytes. Here's the actual first zombie. Let's see if there's anything odd that we can kind of compare against. So my first notice is the first thing has 254. So let's go another 8 bytes. I'm actually just going to search for it. 256. 254. Okay, so that's something unrelated. I'm trying to see, second one being 16. Second one being 16. In our case, we are 1. So we can possibly do a check. So the first offset in the entity, second offset, might be the ID or something along those lines. So we can check and see if that is equal to 16. So let's do a quick check. So we have the entity, yada, yada, yada. We go through and we do the draw. So we're going to do another check right here. So int, what was the type? No. An integer. So integer test val equals memman. Read mem. Integer entity plus 4 bytes. And if test val does not equal 16, we can continue. Let's give it a try, see what happens. And there we go. So that kind of fixed our bug there. But nerd. Oh, he died. So that now fixed our our issue. I can't imagine there will be anything else. So I'd imagine if we go to dir_res, when we check the dog round, there might be a problem. So I'm going to go ahead and pause the video and head over there and check just to confirm. Alrighty, I'm finally back and I now have a dog round. So actually, it works for dogs as well. And we're not seeing anything odd about it. I can actually pause the game and we can look through. And wait, no, that's the first entity. Go to the second one. Same kind of information, 1C8 is 1600. So these dogs have a health of 1600. So what I can do is I can resume. I'll shoot one of these. Is this the fun one? Yeah, that's the fun one. Shoot him once, shoot him once. And actually it dropped right down to 260. Shoot him once. Shoot him, okay, I guess more than once. 120. And that killed him. So we now have our ESP set up and working and good to go. I'm seriously missing? Yeah, screw it. I'm just going to quit now. Anyways, we are done. So, close you down. There is our ESP. So, as I stated before, all this code will be available in a GitHub repo. All you have to do is just join my Discord that's linked down below. And there's just a little section for cheats in there that you can find the link for this. If you like what I'm doing and you want to help support me, you can find a link to my Discord or my Patreon down in the description below, where I create a team deathmatch tutorial from the ground up using C++ with Unreal Engine just for my patrons, where we cover a bunch of other features such as obviously team deathmatch and things like a weapon customizer, spawn points, and all that. If you have any questions or anything like that about game development or what I was doing here, feel free to join my Discord down below as well, and I'll try to help you out. So, as always, I'll see you in the next video.